This was our title, equation of a linear regression. And this is the situation where question has given us an equation. And I told you that line of best fit is not always by normal vision. Line of best fit can also be drawn by a given equation. Last time we discussed that for example, this is a scatter diagram and you have drawn a line of best fit. You can draw it by vision. And in our A level, it happens that there are two types of regression lines. One is called, which is very common, is called Y on X. And look, what is the second one?
Yeah. Yes, we discussed this. Yeah, Y on X or X on Y.
Yes. Now, this was an example from the website, Save My Exam. This is a scatter diagram, and he had given us the equation. Now, here we are not supposed to draw the line by our vision. We are supposed to draw it. By our equation. Draw the regression line on the scatter diagram. We had discussed that we should make a table as we used to do in our normal O level. And then we plot a line precisely, that is the line of regression or line of linear regression. Then he says, interpret the meaning of 18 and 1.3. And this is a concept that it is a comparison with y is equal to mx plus c. And 18 is the y-intercept and 1.3 is the gradient. Last point, which we discussed, and I said that this is always a tricky part, that you have to make a comment. And normally it should be remembered that it is always a tricky part, and you have to read the question, you have to see the graph, you have to see the origin, and then you have to answer. Now, this is an example from the Edexcel official book. That table below shows data on the number of visitors V in 000s and the amount of money they collectively spent for each of 8 months. The equation on the regression line of M on V is this. So it means equation is given. Give an interpretation of the gradient of the regression line. What is gradient? Remember that gradient is always y upon x. So here, gradient will be y upon x. Y will be the amount of money spent, and x is the number of visitors. So now read the question and think about the concept, what the gradient shows here.
Okay,
gradient is always y upon x.
Yeah, yes, sir. Yeah. Okay. Y upon X. Okay.
Yes, I'm waiting. Please be quick.
Yeah, just a second, sir. I'm getting it.
No, you're not supposed to draw anything.
Oh.
Are you?
No, I'm not drawing anything. I'm just finding it.
Huh? Finding it? No. You're not supposed to find the gradient.
Then, sir?
You have to physically explain it.
Or like how I would get it? Like, sir, I mean,
gradient,
okay, wait.
for example, you will tell the examiner that, look, gradient is y upon x. Here,
so you have to tell which one is y, which one is x, basically.
So it will be amount of money spent per unit number of visitors. Just like if I ask you as a physics subject, if you remember that what is the gradient of speed time graph? You will say acceleration. Why? Because what is speed upon time? This is acceleration. So remember, gradient is actually upon. It's a ratio of y to x. Second line is y, first line is x. So the gradient is actually y upon x. it shows
Mm-hmm.
money spent per visitor. It means it
Okay.
shows how much money each visitor spent. So you will tell the examiner that, look, gradient is always y upon x. It means it is money
Spent upon visitors.
money spent per visitor.
Per visitors.
In easy term, it means how much money one visitor spent.
Mm-hmm.
So this is
Okay.
an interpretation. Interpretation means you're not supposed to calculate it, you're supposed to explain it.
Okay.
Now, use the regression line to estimate the amount of money. Here you have to use the equation given and you have to use a calculator.
Okay, sir.
So he says that amount of money spent when the number of visitors to Ireland in a month is 22000000.
Yeah. Wait. Okay. Yes, sir, for part A, give an interpretation of the gradient. Okay, you just have to say that. All right.
We have to say this thing now. How much money is spent on average? How much money is spent by one visitor? The part A I'm talking about. If you're talking about part A, part A means gradient. You're not supposed to calculate the gradient.
Yeah.
Gradient shows how much money one visitor on average will utilize, will consume. Use the regression line to estimate the regression line to estimate the amount of money spent when the number of visitors in the month of is 22. So I have the number of visitors that is 22000000. So put them in the equation. You can solve on
This
the copy and then we
yeah.
can compare. You
Okay,
have the
sir.
equation. Look, equation is V is equal to
Minus
467
467. Yeah.
plus point
740 V.
So this is basically line of M. So it is, no, actually it is here. It is,
Yes, so instead of V, we can write 2200.
no, actually it is, I have to make this word that it is, the equation is Y on M.
Yeah.
Equation is M on V. So this is M and this is V, 0.740 V. So the M is the money you are looking for, minus 467 plus 0.74 0.740 into 22000000. This is the calculation. So do this calculation.
Yeah, I'm just getting it, sir. Sir, I'm getting 1627533. Wait, I'll say it again.
162.
1627533. Yeah.
So we have to, but why it's getting, why our answer?
So we can say 1.6 million, right? Yeah.
No. Something is wrong. Actually, you know what? It was in 000s. Oh, actually, the question was saying it is in 000. So already we had made a mistake. We shouldn't have put the 22000000. We should
Oh,
not have
just should have
put
put this.
the last 3 zeros. We should not put.
Okay.
So now you have to do this calculation again.
Yeah, sir. Then I'm getting 1161.
Okay. What digits you are getting? 161. 161.
1161.
1161.
Yeah.
Okay. 1161. 1161. Acha, comment on the reliability of your estimate in part B. So you need to make a comment on it. The graph is not there, but that's why the comment can be made directly on the appearance because of the question. There's no graph. So we can't say it's a high correlation or it's a low correlation. Actually, the comments in this chapter mainly comes from the idea that it's a strong correlation or weak correlation or positive correlation or negative correlation. Nothing is there like that. We could not have a graph. So he says comment on our answer is 1161. So now if I see my graph, sorry, my table, when it is my number was 2200. If you see your equation 2200, you can find a number close to it. Look at any number close to 2200.
2200. Wait. This one is the closest. 2290.
Huh. And it is 1210.
Yeah, 1210. Yes, sir.
And look at the 2352290 and 2200. If you see the number before that, 2350.
Yeah, this one.
Yes. So if you see these two numbers, you can find that our number is actually not fitting in between. So if I have 2350, 2290, one number is 1270, 1210.
Yeah. I get it, sir. Okay.
What you got, Pata? If I am standing somewhere between these two numbers, my answer 1160 is actually not fitting up.
Yeah, it's not, sir. Like it should come either before or after it.
Oh.
No, it should come before it. It should like it won't fit in between. Exactly. Yeah.
So you can say that the reliability is low because the data, look at the data from the data 2350, 2200 come after 23. This is coming in between somewhere. But my data is saying 1270 and 1210. So reliability is low. Why reliability is low?
Like maybe it's
Look at the
out of the range
table.
or
Look at the table. Do you think if I put a question mark here somewhere 1160, 1161, does it fit in the trend going on in the second line?
it won't, sir. It won't fit in.
Because actually 1160 is not coming here. So on the basis of this, you can say that it's a weak reliability factor because our number is not coming in the expected trend.
Yes, sir. So we can say that it's not reliable. Like it's low reliability is there.
Okay, so we are done with that. Now give the heading equation of a linear regression line using the method of least squares.
Least squares. Okay, I give this heading.
You have to copy, you have to give this new heading.
Okay, so done. Yes, sir, I noted it.
Now, least square regression line is a method which is based upon a new concept which is called gap or residual. What's the concept of gap or residual? That when you plot a graph like this is a line of best fit and the crosses are coming from the scatter diagram. This is called the line of best
That's
fit.
fit.
Now, this line is going between the crosses. Now, any cross has a separation from the line like this. This gap is residual. Any
Residual.
cross, any cross has a gap from the line. This gap is called residual. So this is the concept of this method. This method says that we have to find out how much is the deviation, of any point, how much is the deviation of any point from the line of best fit.
Okay, wait.
So now you have to first copy this thing.
Okay, sir, 1 second. Residue. Okay. Yes, you're done.
Now, this is the concept of gap or residual. This gap is called residual. It is the difference or deviation of any cross from the line of best fit. You have to copy this.
Okay, sir. Yes, sir.
This diagram
Yes, sir, I
shows
made it. Yeah. Yes, sir.
this diagram shows the concept of residual. Have you copied it?
Yes, I copied it.
Now, the residual points are across the line, and every point has a separation. Every point has a separation from the line of best fit. Now we have the formula. The equation of the regression line of y on x is, look at the formula, y is equal to a plus bx. We have already discussed this line. Now we are discussing that how these values come up. We remember B is the gradient and A is the y-intercept. How we find B? B has a new symbolic language, SXY upon SXX. And A is a coded language, Y bar minus BX bar. Achha, these new language, SXY, SXX, they look very confusing, but actually they are used in this way because they use two set of data. For example, SXY is equal to sigma XY. SXX is equal to sigma x squared. Stats sometimes use this type of blind formulas, but you have to follow them. So now these are the formulas to use to calculate A and B. Why A and B are necessary? Actually, we need A and B so we can mount the equation of the line of regression. So you have to now copy this.
Okay, sir.
Now, these formulas are separately calculating SXY, all the summaries.
Yes, sir. Sir, I'm with the last formula. Just a second. Yeah, yes, sir. There, like the summary. This was also used in the what's that called, the previous chapter also. Like just a like a simplification of it.
Now, look at this point.
Yes, sir.
Now, look at this formula. Now, we remember this. Now, this is an example. The results from an experiment. Let me share the question now. I have sent the example on the chat so that the question is with you. And now you give the reference number as our yesterday discussion that these type of questions will be there on the chat. And if we write a reference number, we can connect them here. So Okay, we have to read the question.
Yes, sir. I see the question.
Now you have to.
Yes, sir. I have the question. Okay.
Okay. This is,
Yeah.
I'm
Yes, sir.
writing reference number 2. So write under it reference number 2 in your, give the title example reference number 2. Benefit of writing reference number 2, that whenever you want to see this question, you will type reference number 2 in your exam, in your WhatsApp search, and you will get this image.
Yes, sir.
Now look at this.
Yes, sir. Okay. Yeah, see, I saw the question sets like telling us to calculate SXX and SXY. So yeah, we have the like the formulas of it, so we can just substitute and find out the answer. So do I do it
Ah,
now?
but we have the values. We have all the values. Calculate
Yeah.
SX. Okay, fine. So now you can calculate SXX. First, you calculate that these two variables.
Yes, sir, I'm finding it. I'm finding SXX right now. So what
Ah,
we would do, yeah, we would just
yes,
like use
mm,
the formula we just wrote down.
yes. Simply, you have to remember that rounding should not be done until you reach the final answer. Do not always take minimum rounding.
Okay, so for SXX, I'm getting 400, 4,000 divided 22,000 minus 300 squared divided by 5. So I'm getting
Mm,
4,000 for it. And for SXY, I got 922.
Yes, very good. Calculate part B. Calculate the regression line of y on x.
Y on X, okay. Yes, I'm finding it using the formula like B equals to uh, SXY divided by XX. So I'm getting the value of B as 0.2305, and then I'm getting the value of value of Y. Just a second, sir. Like I'm finding A and then I'll get Y once again. Okay, sir, for the value of A, I'm getting 43.9, and then the value of Y, I'm getting like, I wrote it as an equation.
But do not round much.
43.9 plus.
Try to
Huh?
have at least 2 decimal places at least.
Okay. 2 decimal places, so yeah, then 43.89.
Hmm.
Okay. Yes, sir, I got the same thing now.
Hmm. Now look at the next part. He says, use your equation to predict the length of the spring when the applied mass is 58 kg. So X is 58. You have to put it in this equation. You have just formed.
Yes, sir. Sir, I do part C now, right?
Hmm. Yes,
Yeah,
part
I'm
C.
getting it. Hmm. Yeah, I'm just doing it. Just a second, sir. Okay, sir, for part one, C part one, I'm getting 57.3, and wait, no, no, 52 decimals. 1 second.
So answer is
Yeah,
coming
I'm
to
getting 57.226, and then I'm getting 73.9. Yeah, or 73.85.
now see the second part.
Okay, D part, right? I think they're talking about the reliability of the predictions.
Yes. Now this is always the tricky part.
Yeah, okay. So what have they said? Have they said anything different? All right. Okay, so if we see, like, I'm just looking at the data set, like, how we discussed yesterday about, data within the range or not in the range, like that. So, I mean, if we see the data they have given, they gave like 58. So it comes like, it can come in between
It
this
is in
part.
the data.
Yeah,
So
but
you can tell me,
30 is not coming. 30 is like, 130 is above like 100.
say, so one is
What
in
have they?
within the range and one is outside the range.
Hmm.
Okay,
So
now
correct.
give the new heading. This is now we are towards the end of this chapter. This title is called Product Moment Correlation, PMCC. So you have to give the heading Product Give the heading product moment correlation PMCC.
Okay. Okay, sir, I wrote it.
Now, the idea of product moment correlation, what is the idea of product moment correlation? The idea says that after working out the equation of regression line and after working out the concept of correlation, as always, stats need is that one number, we call it magic number. Like for example, mean is a single number which can represent a whole population. Median is a single number. We can represent the whole set of data. Stats always look for a single number. For example, when we are studying in a university, we use the word the value, which was the GPS values and other values which we consider as the performance parameter out of 4. So he said, what is your GPA? So this GPA is a single number. So this is a concept of single number. Stats says that multiple numbers cannot describe a situation. A very interesting example, which is always given, a very interesting example, which is always given, that which is always given, a very interesting example which is always given is the our age. Our age is a single number which tells about our period of time spent here. Now, this number is never exact because age is every day increasing, but we use this number. There are many other numbers, like in chemistry, there is a number called pH. So now make a concept that they were looking for a number, a value, single value, which can determine the level of correlation. What it means that there are different types of correlation, positive, negative, no correlation. Now they were looking for a number which can tell us that what type of correlation is there. So product moment correlation coefficient, PMCC, is a way of giving a numerical value to linear correlation of bivariate data. So you have to now copy this.
Okay, sir. Yes, I wrote it.
Okay. The PMCC of a sample is denoted by the letter R. R can take any value between -1 to 1. What is the concept of PMCC? Actually, PMCC is a number, a single number, which shows or which describes the nature of correlation. What are the possible natures? Like positive correlation, like negative correlation, like no correlation. They can be denoted by this number. So you have to copy this.
Okay, sir, wait. By the letter R. All right, wait, I'm writing it, 1 second. Yes, sir, I wrote it.
Hmm. Now look at this. For a positive value of R, describe a positive correlation. If R is negative, it describe a negative correlation. If R is equal to 0, no correlation. If R is equal to 1, it means perfect positive correlation. I will share this sheet. This is very logical to memorize. Do you remember what's the positive correlation? When one quantity, one variable increases and the other variable also increases. What is a negative correlation? One variable increases and the other variable decreases.
Yeah, yes, sir. It's like all the opposite.
Okay, now you have to memorize this. I will share it for memory, but it's so logical to remember. When R is equal to 0, it means no correlation. There is no relation between the two variables. Now look at this. When R is equal to 1, R is equal to 1, and R is equal to 1. Can you see the 3R is equal to 1? The high correlation, it means the crosses are nearly on the line. They have a very little scatterness. Acha, R is equal to -1. It's a negative correlation. 1 means high correlation. Acha, R is approximately 0.7, but a positive number. So it means the line will be going upward. R is equal to 0 means no correlation. And R is equal to 0.4 means negative correlation. 1 means the points will not be scattered much. The gradient of the regression line does not change the value of R. There are just like, what's the regression line equation? Y is equal to A plus BX. Y is equal to A plus BX. Now that gradient, which is the value of B, will not affect the value of R. Okay, so you have to copy this concept now.
Okay, sir, just a second. Yes, sir, done.
Now look at the formula for R. R is equal to Sxy upon Sxx into Syy. This formula is given in the formula booklet, so you have to just copy it for a reference here. This formula can be used to calculate R. You have to copy this.
Okay, sir, just a second.
Have you copied it?
Mm-hmm. Yes, I
Now,
copied it.
these are the parallel formulas which can be used for n pairs of bivariate data. Sxx is sigma x square minus sigma x upon n. These formulas can be used and they are given in the question. We had also copied these formulas before, and we had mentioned that these formulas here, look, these formulas are given in the data formula sheet. These formulas will calculate Sxy, Sx, and Syy. Okay. So now these are the formulas. Some extensions are also given of this formula, like S double X can be related with sigma x minus x bar, and Sxy can be connected with sigma x minus x bar. These formulas will be used, then they will be understood. They are connected with variance. Okay, S represent variance. So you have to copy this.
Okay, sir. I'll write it.
These formulas are extensions for variance.
Yes, sir. Yes, sir. I noted them.
Now, this is our next question, and okay, let me share the question. Here it is, and again we will be using a reference number for our question idea. This is reference number 3. Okay, so I have shared the file, image, and you will write reference number 3.
Reference number 3. Okay.
Now you have to start this question. Ashika is a football coach to 20 children. She records how long it takes each of them to run a lap of the football pitch, P seconds, and the distance that they can kick the football, D meter. Ashika calculates the following summary statistics like this. Calculate S of PD. So you have to read the question.
Hmm. 1 second. The ball goes to 20 children. Okay. Okay, sir, I got the question. All right.
So now,
Okay, I'll calculate it.
okay, now start part A.
Yes, sir, I'm gonna do that. Just a second. Okay. Sir, I'm getting the value as 782.2. Is it correct?
Yes.
Okay.
Now, second part.
Okay, sir. Sir, I'm getting the value of the relation. I'm getting 0.741. So yeah, first
Good.
off, okay, wait, let me see. So can you show the working for a second? I'll just compare also. Okay, SDD. Okay. Oh yeah. Yeah, we find SDD first and then divide it. Yes. Okay, this is okay. Yeah.
Now, see the last part.
Okay.
Calculate the equation of the regression line of D on P, giving your answer in the form D is equal to A plus BP.
So I'm just getting it, like I'm finding it, just a minute.
Now you have every value. You have the product moment correlation also. Now you have a general form y is equal to a plus bx, which you can convert into y will be as d. So you have
Okay.
the values of the. So are you saying something?
Yeah, so I'm just listening to you. I mean, I was also trying to understand the question. Yes, I'm just looking in the working and listening to you. Yes, sir.
So calculate b using the formula gradient.
Okay.
B is the gradient.
Yeah.
And then calculate d bar as before, and then put the values back to get the equation.
Okay. Wait, the value is back. Okay, we have the equation. And then 1 second. E equals to this. So just give me a minute. I'll just write this working. Just 1 minute. Okay, sir, I wrote it.
So we are done with this question, and this will be an example you have to do later. So I will post it for homework. This chapter is completed, mashallah, and we can
Yeah.
do past paper questions in our next class. Okay. So
Yeah,
we'll
all right.
inshallah continue in our next class. Allah Hafiz.
Okay, Allah Hafiz, sir.